Hi everybody and welcome. Today the skill that we're going to be looking at is adding and subtracting rational functions and expressions. So the goal for today is going to be to take a look at some rational expressions and functions that have unlike denominators and then put those together in a way that combines them into a single term. So just a really fancy way to say that we're going through and doing some simplifying of the terms that we are working through here, and that should hopefully put us in a position to be able to have some success with getting these into a little bit more manageable of a form. So the first thing we're going to talk about is adding fractions. So for fractions in general, we can add or subtract only if we have a common denominator. So in the example of, let's say, like 1/4 plus 2/4, we can put that together and keep the bottom the same and add the numbers on the top. This is our pizza example, so we have pizzas that are cut into fourths. We have one slice, and then we have two slices. So the total amount of slices that we have, if we put everything together, we're combining our leftovers into a single box, is 1, 2, 3 slices, or 3 out of the 4. So it's basically saying, put this together, we get this. So that's also the reason why it doesn't work if the bottoms aren't the same, is we don't know the number of slices because they're all different sizes. So in the situation where we have 1/4 plus 1/2, if we draw out our pizzas, we now have two different types of pizzas. So just a quarter slice, and then we have a half slice. So the way that we can basically make these fit into the same leftover box is we're going to have to take our half slice pizza and make another cut. And if we make another cut, then we can see a common denominator. We can also see an equal number of slices come together. This one gives us 3/4. So that's the reason why a common denominator is important, is because we got to be talking about the same size slices when we're combining pizzas. So the same thing happens when we look at fractions with variables, is we have to be dealing in the same terms. So on the bottom, we have to be the same. And if we are the same, we get x on the bottom, and we're happy. So now we can just take the top and add it. So on the top, we just have positive x squared and positive 3. And that's all that we can do. The top can't be factored any further. Nothing that can cancel on the top or the bottom. We just put together some things that have the same bottoms and combine them into a single term. Similarly, for the next one, if there's multiple things on the bottom, that's okay. We just have to make sure that they're the same. So in this case, x minus 3 is the same. So what that allows us to do is, again, take a look at the top. So x squared minus and 9, and put it together like so. Now the key here, though, is we have to be mindful, can we factor further? So something like x squared minus 9, if we were to put that into a box, what that's going to allow us to do is to get positive 3 and negative 3. Our diagonal cancels, and we get x squared minus 9. So a really fancy way of saying we can simplify this further by factoring the top. And when we factor the top, what it's going to allow us to also see is that we have something that simplifies. These two are the same thing, so if we put this in lowest terms, we can simplify it to just x plus 3. So kind of putting a few of the things that we've learned together in order to get ourselves to a spot where we're in lowest terms. So next, we want to look at the same thing, but this time when we don't have common denominators on the bottom. So there are two different ways to go about this, but both of these methods to solve this start exactly the same. And that method is, if you see anything that you can factor, you must do the factoring first. So in this case, both of our denominators have things that can be simplified from them. So x squared minus 49, we could change that into 2 over, put this into a box, and we should get x plus 7 and x minus 7 here. For our next one, we see even numbers. So what that tells us is we have 2 that can be factored out into 2x plus 7. So on the bottom, what we're saying is, okay, we have some common multiples for common factors for 2 and 14. The common factor for 2 and 14 is 2. We take out that common factor, and it gets us to a simplified form. So here is where the two methods that we can use kind of diverge in some ways. So we're going to do method number 1, and then we'll immediately go to the side over here and then work through method number 2. So I'm just going to rewrite the question to show us the two different ways that we can solve this. So for both methods, the first thing that we want to do is focus in on our denominators. So we have two different ones. We have x plus 7, x minus 7, and we have 2, and we have x plus 7. So we can see right away is they both have x plus 7 in common. So because of that, what that tells us is x plus 7 is a key factor in our denominator, our common denominator. The second thing that we have to do is put together the pieces that they don't have in common. So they don't have x minus 7 in common, and they also don't have a 2 in common. So by doing this, we can represent, and I'll actually color code this, the three different terms that we have in our denominators. Now, a common denominator would have all three of these things because it would have all of them in common. So it would have green, it would have blue, and it would also have yellow. So in this case, neither of them have all three of them. So that's going to be our job, is to actually go through and work through these so that we do end up with all of the colors. So the two different options that we can do, and we'll call it method 1 and method 2. So method number 1 says that we get common denominators. And this is how I have always done it. So this is a root and personal method. I use this when I solve these questions. So we find whatever we're missing and we multiply the top and the bottom. So color that's missing, multiply top and bottom. So in this case, our first term is missing blue, so we're going to multiply the top and the bottom by blue. And our second term are missing yellow, so we're going to multiply the top and the bottom by yellow. And when we do this, it's going to give us a common denominator. So by simplifying here, 2 times 2 gets us 4. And then we have our common denominator here of 2x plus 7, x minus 7, and then plus 3x times x minus 7. So we are just combining, I'll show us here, our red term here with what we did on the other side, 2 and 2, to get us 4. So putting the pieces together. So from here, continue to simplify, so we'll have 4 plus 3x squared minus 21x all over 2x plus 7, x minus 7. So in this case, something that we would look into the top is going to be further factored. Given the numbers that we have, a great way to check if you punch that into your calculator for quad form. For right now, we're not going to do that because we accomplished our goal of putting everything together with a common denominator. Now the second method is something that I think a lot of people prefer to do, and this is multiply by the common denominator. So I'm actually going to rewrite our second term to give us just a little bit more space here. So our second term is so what we are quite literally going to do is multiply by the common denominator. And what this is going to allow us to do, and again, we're going to do this on the top and bottom. And what this is going to allow us to do is get into a spot where we have everything basically being completely simplified here. So we're going to take all of the terms that we have. So multiply here by, I'll write this in our colors, 2x plus 7, x minus 7, by 2, x plus 7, x minus 7. So multiplying each of our terms from that common denominator in a way that helps us work through. So by doing this, it's going to allow us to get to a place where everything is simplified. So we can see things that we already have. X plus 7 cancel out, x minus 7 cancels out, so 2 times 2 gets us 4 for our first term. And then for our second term, x plus 7 and x plus 7 cancel out, 2 and 2 cancel out, so we're left with 3x, and then x minus 7 is left over here. So in this case, again, we have just focused in on our numerators when we're solving, so the 2 and 2 to get 4, and then 3x and x minus 7 right here. And we can't forget that we also have our same common denominator, which we already know. So the same common denominator, just writing it down here again. So this is the second method. So again, just multiplying the top by the entire common denominator and then writing it on top of or over the same common denominator. And what we're going to see is when we distribute this in, we get exactly the same answer. And for some, this method is a little bit quicker because we get to cross some things out. We don't have to think as much about which factors we put in for our denominator. We just simply do it. We just cross it out and we're good to go from there. But the key to both of these is we have to know our yellow, green, and blue. And if we know our yellow, green, and blue, then we know the common denominators that we're working with. So hopefully this helps for today. Basically, the big idea here is determine your common denominator and then see, would you rather just multiply the tops by that common denominator, or would you rather set all of your terms with a same common denominator and then go through and solve from there? So a challenging skill today working with fractions, and